Today, we'll be looking at how a new bionic eye could give robots and the blind 20/20 vision. If you're new to this channel, welcome. This is Mr. Singularity, where we explore the scientific and technological breakthroughs shaping the future as we know it. A bionic eye may restore sight to the blind and significantly enhance robotic vision, but existing visual sensors are a long way from the amazing hardware attributes of nature. Researchers have now found a way to replicate its structure and create an artificial eye that reproduces many of its capabilities. The main part of what makes the eye's design so strong is its form, but it's also one of the hardest things to imitate. The concave form of the retina, the photoreceptor loaded layer of tissue at the back of the eye, makes it possible to pick up even more light as it passes through the curved lens than it would pick up if it were smooth. But the reproduction of this curved sensor array has proved difficult. Much of the previous approaches focused on making photosensors on flat surfaces before folding or transplanting them onto curved surfaces. The problem with this approach is that it restricts the density of the photosensors and thus the resolution of the bionic eye, since space must be left between the sensors to allow the transition from flat to curved. However, in a paper published last week in Nature, researchers at Hong Kong University of Science and Technology devised a way to create photosensors directly into a hemispheric artificial retina. This helped them to develop a system that could mimic the wide field of view, responsiveness, and resolution of the human eye. The structural mimicry of GU and the artificial eye of colleagues is certainly impressive, but what makes it truly stand out from the previous reported devices is that many of its sensory capabilities compare favorably with those of its natural counterpart, says Hongru Yang, an engineer at the University of Wisconsin-Madison. From a nature perspective, the secret of the breakthrough was an ingenious way to insert photosensors into a dome-shaped artificial retina. The team developed a hemisphere of aluminum oxide peppered with tightly packed nanoscale pores. They then used vapor deposition to develop nanowires within these pores made of perovskite, a type of photosensitivity compound used in solar cells. These nanowires act as an artificial photoreceptor equivalent. As light passes over them, it transmits electrical signals that are picked up by liquid metal wires connected to the back of the retina. The researchers created another hemisphere made of aluminum with a lens in the middle to serve as the front of the eye, and filled the gap between the lens and the retina with an ion liquid designed to imitate the fluid aqueous humor that makes up the bulk of the human eye. The researchers then connected the bionic eye to the device and showed that a number of letters could be recognized. Although the artificial eye did not quite match the 130-degree field of view of the human eye, it managed to achieve 100 degrees, which is a significant improvement over the approximately 70 degrees flat sensor. However, in other areas, the technique has the ability to enhance biological eyes. Researchers have found that nano-wide photodetectors are actually considerably more sensitive. They were activated in as little as 19.2 milliseconds and restored to a point where they could be reactivated in 23.9 milliseconds. Answer and recovery times for human photoreceptors vary from 40 to 150 milliseconds. The number of nanowires in the artificial retina is also more than 10 times that of photoreceptors in the human eye, indicating that the device will potentially reach a far higher resolution than nature. At the moment, the major limitation is the wiring of these photosensors. Liquid metal links are actually 2 orders of magnitude wider than nanowires, so that each connects to several photosensors, and it is only possible to mount 100 wires to the back of the retina. This means that despite the density of the photosensors, the eye has a resolution of just 100 pixels. The researchers have invented a way to use magnetic fields to bind nickel microneedles to only 3 nanowires at a time, but the process is a complex manual process that would be difficult to scale up to the millions of nanowires present in the artificial retina. Even, the device is a promising proof of concept that indicates that we will soon be able to reproduce, and even better, one of nature's most beautiful designs. Given these advancements, it seems possible for us to witness the widespread use of artificial and bionic eyes in daily life in the next decade. What's your take on this? Would you get a bionic eye? Let me know down in the comments below and check out one of these other videos. This has been Mr. Singularity, and I'll see you on the next one.